Hi, welcome to our session Serverless Functions, FaaS, that is secure, scalable, resilient, anywhere. My name is Vinod, and I'm a product manager at Google, and I'm presenting with my colleague Dustin Ingram and Matthew Lawson from IKEA. So let's get started. So here's today's agenda. First, we'll give you an overview of the product cloud functions. Then we'll walk you through key function as a service use cases. Then we'll follow up with an interesting case study from IKEA and their digital transformation with serverless. After that, we'll walk you through key security capabilities and diagnosability and availability capabilities in serverless at Google Cloud, and then walk you through our functions everywhere vision. So let's get started. Cloud Functions. Cloud Functions is Google's event-driven serverless compute platform where users can write small snippets of code that react to events as well as HTTP. You can write up these functions very easily and get started to process small snippets of code for, say, for example, uploading a file to Google Cloud Storage and do some processing. Also wrap up with some ML APIs, do some ML processing on the file, and then store the results back in the cloud. Cloud Functions is truly serverless, where you pay only for what you use. It scales seamlessly with zero infrastructure management. It also has a streamlined development model where you wrap up and write a function very quickly. In addition, it's integrated with key events all across GCP to build up complicated applications and services. When we talk to users really like to use Cloud Functions for its simplicity, scalability, the fact that you don't have to manage servers, the pay for use model, and the fact that it's connected with a broad range of cloud services. Key functions as a service use cases that our customers use Cloud Functions are things like serverless webhooks, where users can write up functions with GitHub notifications that are processed and then served in Slack. Further, real-time data processing, wherein users can upload data to the cloud to cloud storage, trigger a function to do some processing, call an ML API, and then store the results in the cloud again. Serverless IoT backends, where users have IoT systems all across the world sending things like sensor and temperature data, and then that's processed through pub sub messaging systems that trigger cloud functions, and then you do some IoT analytics and then store the results in the cloud. And then intelligent applications using AI in BigQuery, for example, chatbots using Twilio, where functions are wired up to invoke an ML API or a natural language processing API, as well as doing sentiment analysis with that and trend analysis with BigQuery. Along with these key FaaS use cases, when we talk to customers, they have several key FaaS user needs that come up. And these needs are things like developer productivity, building complex enterprise workflows with serverless and functions, building applications that are secure, and then having the ability to build applications with multiple languages, with diagnosability, debugging capabilities, telemetry, and local development. Further, users will care about global availability and scalability to ensure their application and functions scale for their application traffic. In addition, users really care about portability and can we reduce vendor lock-in when we build our serverless applications. And to meet these user needs, Cloud Functions offers the following key differentiators. First is ease of use. Cloud Functions is a very easy to use product where users can write up a function very quickly from the UI, from the CLI, from their favorite IDE, and from an API. For example, here's a simple function in Node.js where a user's just written hello cloud next. The user quickly wires it up and deploys it using the CLI, and then it's ready serving traffic. All in a single command. The user's writing their code, it's getting built in the cloud, it's getting deployed in the cloud with health checks, and then it's within minutes running and ready to serve traffic. This is really powerful that all in a single command, a user can get this and achieve so much. Along with the ease of use, Cloud Functions offers the ability to build complex end-to-end solutions. These end-to-end solutions can be built using key powerful building blocks, which are event-based for things like data processing with ML APIs and BigQuery and so on. And then for automation workloads with things such as Cloud Scheduler, Cloud Tasks, and so on and so forth. And to walk you through this application journey of building end-to-end applications, I would like to now invite Matthew Lawson from IKEA to walk you through IKEA's digital transformation with serverless and cloud functions.
Hello and good morning, good afternoon, or good evening, depending on what time it is, wherever you're watching this. I'm very happy to do this presentation for you today, but of course I would love to have done this in person, but because of the current global situation, I get to do this from my home office here in Sweden. So in this talk, I'm going to explain to you how IKEA is using Google Cloud Functions and other serverless technologies in our engineering efforts as we go through a digital transformation. So my name is Matthew Lawson, and I work at IKEA as an engineering manager here in southern Sweden. I usually don't start my presentations off with who IKEA is, but I do have a couple company slides, 2 of them to be exact. So first, maybe I can share something that you might not know about IKEA, and that is our vision. It has very little to do with furniture, actually has nothing to do with furniture, and that is to create a better everyday life for the many people. So whether it's becoming one of the world's leaders in sustainability, starting to sell solar panels, working with international charities, or creating that great furniture for the home, all of this to help the many people to create that better everyday life. But the 2 words out of that vision that mean the most to me are many people. And to let you know what I mean, let me give you some numbers here. So IKEA is over 76 years old and is made up of many companies, organizations, and hundreds of thousands of coworkers across the globe. So here are some highlights from our previous fiscal year as of September 1st, 2019. So IKEA had 433 stores open, with 12 of them opening that fiscal year. And actually within the last few months of this recording, we have over 450 now. We have 211,000 coworkers working for us globally, and this is growing, especially in our digital organizations across the globe. And we're now opening small stores in city centers. As an example of this, within the first 4 months of opening, we had 1 million visitors to our IKEA La Madeleine store in downtown Paris. We have billions of visitors to our website each year, and we have over 100 million IKEA family, or our loyalty program, across the globe as well. So this means that when we create a new physical product or a new digital product, like a mobile app, web application, or an API, we need to make sure we cater to those many people, the millions of people. So IKEA, as in many different companies, are going through a digital transformation. IKEA has been around since 1958, and to be completely transparent, we have quite a bit of technical debt across the organization, or what we like to call it as our spaghetti in the data center. Our digital transformation was not simply a matter of migrating to the cloud. One decision we made early on was how this was going to happen. We did not want to do a complete lift and shift to a cloud partner, but instead, we decided to re-engineer the organization and digital products at the same time. Our chief operations manager stated once, "We are flying a plane and changing the engine at the same time." Personally, to me, this is quite hard to do, but as an engineer, it has been a ton of fun. So new solutions and projects are striving to be completely cloud native, and this is quite hard to do when the brain of your application, the data, is still sitting on premise. And we're doing a lot of work in that area internally as well, creating new data pipelines to cater both the old and the new. So one of the use cases that we started re-engineering that is heavily using Google Cloud Functions and many other serverless technologies is our almost live feed of our inventory system that we have at each IKEA location across the globe. So this enables us to show a live feed of what is selling, allowing us to export that data to BigQuery for further analysis, and also to create dashboards to give the store insights on what is happening instead of that daily or weekly report. And I'm sure there's much more use cases that we haven't even thought up of yet here. So let's take a look at an architecture of one of the use cases that my fellow coworker Michael created. First, we have our inventory server, which sits on premise at each IKEA location and talks to the Google Cloud through a compute engine from a shared VPC on a VPN. And this sends many different messages as XML. The XML is then compared to Google Cloud Storage, looking for new or changed rows. And the ones that are changed are sent as a JSON object to a pub subtopic. We then have a batch receiving side of this, which uses Google Cloud Functions and actually powers this entire architecture. This pulls in messages from PubSub and puts the raw data into many different BigQuery datasets depending on the message type. And we can also move that message on for further processing using other PubSub topics. Finally, we're pulling in the messages from the capturing Google Cloud function using a schedule system as well that was built. And this is using Cloud Scheduler, another Google Cloud function, Cloud Tasks, and this configuration data is stored in Firestore. So this tells the Google Cloud Function, the capturing one, how often to execute, depending on some criteria like the amount of messages in the queue, time, and also optimizes everything from a cost perspective as well. We then can create custom dashboards using the BigQuery datasets, and we can also process it further on, like I said, with pops-up topics. One aspect of this architecture that we're currently working on is the ingestion of data from the on-premise server to the cloud. We're looking at how we can do this without using a VPN tunnel or a shared VPC. So some people have asked me, why are we using Google Cloud Functions here and not something like Dataflow? Well, one thing we like to say here at IKEA is we do not respect a solution until we know what it costs. And if this solution was to be turned into mission critical, then we could change the architecture to better support message ordering, duplication, and other aspects. This solution currently handles between 60 and 40 to 60,000 messages per minute, and can certainly scale higher as we've seen. And it actually costs around $30 per month to operate to get the data from our on-premise to Google Cloud Functions. And so this really showcases the power of serverless without needing to spend a ton of money. So let's take a quick look at a demo that my colleagues Axel and Joel created to show what you can kind of do with this data. So here's a map of North America with our stores, and for fun, we're just showing our inventory changes from our iconic product, the Fracta Blue Bag. So as you can see here, we're getting some messages popping in from sales that are happening in those stores. And this really kind of showcases how you can use serverless technology to bridge between what you're doing on-premise to new cloud technologies. So with that, if you have any other further questions, you can please feel free to contact me. My email address is here. And also, as I mentioned, we're also hiring. So please visit join.inca.com for more information around that. And with that, I thank you for listening, and please stay safe out there.
Thank you, Matthew, for that amazing presentation on IKEA's digital transformation with serverless and cloud functions. Now, moving on, one of the key user needs as well as security, and cloud functions offer key security differentiators for users in serverless. One of the key features we offer is per function identities, where we provide fine-grained control on which users are privileged to invoke a function. And we take it a step further and also provide on which specific resources a function has access to. For example, here's a user who's trying to invoke a cloud function using Cloud Scheduler. And that user is authorized and the user can invoke the function. And then there's a malicious user who's trying to invoke the same function and is prevented to do so. Likewise, here's a cloud function that has permissions to access BigQuery, but it does not have permissions to access cloud storage. By providing these fine-grained controls on security, we really help users control who can access the function and which resources the function can access, and then take the security level a step further. Along with that, users really care about VPC. They have systems across the cloud as well as on-prem in VPC networks, and our cloud functions play really nice with these VPC networks. Functions can connect with these VPC networks, and we take it a step further by providing what is called VPC SE, or a security perimeter, to prevent things like data exfiltration. Along with fine-grained access and VPC, users are really concerned about the denial of wallet attack in serverless. For instance, if a user's service gets a lot of requests from a malicious user, they could at the end of the month get a shocking bill if their scaling is not capped. To prevent this, we offer a service called Max Instances that let users cap their serverless services, thereby preventing the denial of wallet attack, and also letting their serverless services scale to the extent as needed and within their monthly budgets. Along with scalability and security, users really care about multiple languages, diagnosability, and local development. Cloud Functions today is available in key languages such as Python, Node, and Go. Further, we're super excited to announce Java 11, which is generally available, as well as .NET and Ruby. And we have more runtimes coming soon as well. And to talk to you more about diagnosability and fault tolerance, I would like to now invite Dustin on stage to give you a demo in this space.
Hi, I'm Dustin Ingram, developer advocate for Google Cloud. Let's take a look at how we can build a reliable, resilient, self-healing system using Cloud Functions and Cloud PubSub. let's say we've got a fleet of deployed IoT sensors that are sending temperature data in degrees Fahrenheit along with a sensor ID and JSON payload via an HTTP post to a cloud function. Now, say we want to take that temperature data and write it to Firestore, which is our operational database, and also write it to BigQuery, which is our data analytics warehouse. Traditionally, we would probably do this in the same application or in the same function, but this has a couple drawbacks. So if, for example, the code that writes to BigQuery is not available, or has a bug in it, or maybe there's a networking glitch and it can't talk to the service, now the function errors out and you're left in a weird state. Should I rerun the function? But then what if Firestore write did succeed and now I've written to Firestore twice? What is the overall state of my application? So we want to decouple these. Now, one way we could do this is to put it into two cloud functions, one that writes to Firestore and one that writes to BigQuery. And this is a step in the right direction. But that post temperature function is still responsible for running and retrying and understanding if those other functions succeeded or failed. So we want to decouple these completely. And to do that, we'll use Cloud PubSub, which is a high-scale messaging bus on Google Cloud. Now, all post temperature has to do is write a message to the PubSub bus, and then it's done. The write BigQuery and write Firestore functions are listening for messages coming in on that topic in Cloud PubSub. When they get those messages, they'll do their functionality, and they'll fail and retry independently from each other, asynchronously. Let's take a look at this in action. Here are the three cloud functions that we talked about: post temperature, write BigQuery, and write Firestore. I've written a shell script to simulate the IoT sensor posting their data via an HTTP post. So they're going to post it to this sensors collection in Firestore, and you can see these values coming in. But we've also got a tracking sheet that we wrote that this actually looks at the timestamps coming in and puts in a message when it's about to try writing to BigQuery, about to try writing to Firestore, and then whether it succeeded or failed. And you can see these update in real time. Everything is good, so it's all successful. But I want to simulate an error in the, let's say, write BigQuery function. So I'm going to open up the editor here in Cloud Functions. There's a built-in editor, but you can also use your normal IDE, your normal editor, to deploy from your workstation and so on. But this is handy for doing quick edits. So I'm going to go here and I'm going to intentionally break this function. I'm going to change the name of the table from readings to, let's just say, readings with a few S's. So maybe one of our Python developers made a typo and put the wrong name of the table. So let's deploy this. So I'm deploying a broken version of the write BigQuery function. And while that's deploying, you can look at some of the other attributes of our cloud function. You can set identity so your function can maybe only access certain resources, or you can set environment variables. For example, the sheet ID that we're doing the updating in. Alright, so now that our function is deployed, I'm going to rerun that shell script that simulates 10 IoT sensor readings coming in. And let's go look at it in Google Sheets. So you can see it's succeeding and trying, and you can see it's happening asynchronously. Those functions are running and failing independently. We've set Cloud Functions to retry, which means that if it gets an error, it will retry immediately. If it gets another error again, it'll wait a bit longer, and so on and so forth, as an exponential backoff. Alright, so those are all failed. So we want to figure out, okay, what went wrong? Now, I know what went wrong because I put that typo in there, but let's pretend that we didn't and we actually need to debug this. Cloud Logging automatically picks up all the logging messages from Cloud Functions, but also Cloud Run, App Engine, Kubernetes, and a bunch of others. And you can see we can identify our error here. The table Cloud Funcs readings is not available. So Cloud Logging is great. You can do monitoring and alerting. You can have it automatically aggregate error reports using error reporting, and it's a really handy and useful tool for debugging your serverless code on Google Cloud. So let's fix our BigQuery function. I'm going to load the editor back up and fix it so that instead of readings with many S's, it's just readings with one S, and then we will redeploy this. Now let's check our tracking sheet where you can see it's actually been retrying this whole time. As it retries again with the new version of write BigQuery, it'll start to succeed now instead of failing. And again, all we did was redeploy the function. We had to set Cloud Functions to retry so the data wouldn't be lost because the system is keeping track of it internally as it retries the function with the same payload again and again until it succeeds. And that'll happen for up to 7 days, retrying your Cloud Function so you don't have to worry about losing data. And that is how you can build a reliable, resilient, self-healing system with Cloud Functions.
Thank you, Dustin, for that amazing demo on diagnosability and fault tolerance. Now, moving on, when users are using serverless and Cloud Functions, they really care about local development and disconnected development. Imagine that you're working in your team and you have to take a flight or 7-hour flight, and you want to continue developing your application that you're working with on your team. You can now do that with Cloud Functions as well as on your plane. And then when you land, you can connect with your team and share your work as well. To do this, let's unpack what's really in a function. A function is running in an operating system for a particular runtime, such as Node.js, with a web framework for that particular runtime, such as Express, with the functions framework, and then with the user's code and dependencies. Everything in green below is managed by Google, and only the user's code is what is provided by the user. And what we have done at Google is we have taken the second green box, which is the functions framework for each language and runtime, and open sourced it. We call this the functions framework. For example, here's the functions framework for Node.js on Cloud Functions. Now, with this functions framework, a user can run a function locally with their favorite IDE. And here's an example of the Node.js functions framework along with a node function in your favorite IDE. And then a user can basically step through code, write code when they're on a plane and debug and test it, and then integrate it with their team when they land down. Along with diagnosability, language, and local development, users really care about availability and scalability for their serverless services. Cloud Functions is available in a broad range of regions, and today we're super excited to announce that we have added 13 new regions over the past year for Cloud Functions, making the total number of regions 19 where the product is offered. With this global availability of the service, we're super excited to provide it to our users in the broad range of markets in the world. Along with availability, users really care about scalability for their serverless services and functions. Cloud Functions is backed by Google's infrastructure, which runs on Borg, and it uses a technology called gvisor, which really helps it scale. And here's an example of a load test where a serverless service for Cloud Functions is sent several thousands of requests, and we see that all of the requests are served and none of them are dropped, and the Cloud Functions scales seamlessly in this test. Along with availability and scalability, users really care about openness and persuasiveness of their application and serverless service. And here's a key differentiator for Cloud Functions in this space, where Cloud Functions, with the underlying functions framework that runs it and the build mechanism to build it, have all been open sourced. As a result, a user can take their function and deploy it to Cloud Functions, which is a fully managed product. They can run it locally in their favorite IDE while they're on a plane. They can also take that function and run it in any environment where you can run a container. This could be Cloud Run, which is our serverless containers product, or any other container environment in other clouds as well. This is a really key differentiator for the product. And now I'd like to invite Dustin on stage to provide you a demo on functions everywhere to walk you through this vision.
If we're a developer who's not used to working with containers, let's see how we can use build packs to take our existing Cloud Function with its simple developer experience and have it automatically turn into a container that we can run anywhere, including the powerful Cloud Run, all without having to understand Docker files or how to create a container. You can use build packs to turn your source code into a containerized application, either locally using the pack command or in Google Cloud Build, which has support in alpha. Build packs will look at the source code of your application and figure out what is the language, what is the runtime, and what will it take to turn your application into a container. So in this case, I'm going to use the local pack build command, and we'll give it a destination, where we want to publish the container. We'll also let it know that it's a Google Cloud function. This is the name of the function within our file that we want to run. So if we go to my container registry and refresh, you can see here is the container that we just built, see just now. And again, containers are portable, so I can deploy to Kubernetes Engine or virtual machines on Compute Engine, but let's deploy it on Cloud Run because it's fully managed just like Cloud Functions. Once you're using Cloud Run, you have some advanced configuration settings, so you can customize how much memory it has, you can give it 2 CPUs, and you have a longer timeout in Cloud Run. You can also do concurrency, so one running instance of your application could handle multiple requests, which might lead to fewer cold starts and more efficient usage. And potentially you can set the minimum and maximum number of instances. Now that is deployed, you can see that Cloud Run gives us a URL, just like Cloud Functions. But you can also specify your own domain name. Let's post some more temperature readings to the app that is running on Cloud Run. And if I pop over here to Firestore, you can see the data coming in. Click here and we can prove that it is in fact going into the Cloud Function that is running on Cloud Run. So we were able to take our existing Cloud Function with just source code and using build packs turn it into a containerized application that can be run anywhere, even the powerful Cloud Run.
Thank you, Dustin, for that amazing demo on functions everywhere. Please check out Cloud Functions at cloud.google.com/functions. Please also check out our functions framework and build packs, which are open sourced. The GitHub links are provided here. In addition, if you have any questions, please feel free to reach out to Dustin or myself. That's a wrap of our session. Thank you, Dustin and Matthew, for joining me in this session. And I wish our viewers a great conference.